we're going to look at the results from our last lab, combination circuit lab number 2, that looked at the voltage and the current in combination circuits and see what it can tell us about how combination circuits work. So here's some example data. This is one of the sets of data that you might have been given. It doesn't really matter if this is not your data because all of the patterns should also be the same. They should look similar. So here we have a circuit where we have 46 volts is our battery voltage. We have 5 ohms and 10 ohms connected in series. That just jumped around. 5 ohms and 10 ohms connected in series. And then we have 20 ohms, and 40 ohms connected in parallel. All right, so looking at our results down here below, one of the things that I want you to notice is that first off, it should stick out here that the current through A and B, through the 2 resistors that are wired in series, the current going through them is the same. That's what we'd expect, actually. If you think about the basic rules of a series circuit, it's that the current in a series circuit stays the same. I is the same in both of them, and the voltage splits up. And that's what we see. They do not have the same voltage drops, but they have the same current. Then if we look at the parallel portion, the current in the parallel portion is not the same because it is actually split up, which is one of the characteristics of a parallel circuit. The characteristics of a parallel circuit is that the current splits up, but the voltage drops across each of the resistors is going to be the same. So let's look at the diagram we have here and see how that makes sense. So if we have 2 amps of current coming out of the battery here, that 2 amps is going to be through all of the parts of the big loop of the circuit. So up until the parallel portion and then after the parallel portion, that's 2 amps. So 2 amps is going to go through our A over here and through RB, but then when it gets down here, it's going to split up. And some of the current is going to go through RC and then go back to the battery. Some of the current is going to go through RD and go back to the battery. And some of the current is going to go through RE and then go back to the battery. So each one of those, if you add them together, they should add up to the 2 amps. So if we have 2 amps coming in here to this juncture, we should have 2 amps coming out of the juncture. And so that they should split up. If we look at this 0.8, 0.8, and the 0.4 values, they should add up to be 2, and they do. 0.8 plus 0.8 is going to give us 1.6, and then plus 0.4 is going to give us 2, so we have 2 volts. And that's one of the major things that can help you solve problems here, is understanding that once you get the current in one part, all the stuff that's highlighted in yellow, in the total current, you know the current through one of the series portions, then you know the current through the other series portion, and you know that all of the currents through the parallel should add up to be that total current. Looking at the voltage drops are different for RA and RB. Hold on, let me erase some of this. So looking at the voltage, if you think about the current, it's going to start with 46 volts coming out of the battery. So we have 46 volts here. The current comes out of the battery with 46 volts. So it has 46 volts, it comes over here, and then it goes through RA. RA is going to take 10 volts. So 10 volts of that 46 goes to RA. Now that means that it's only going to have 36 volts as it continues. So here it continues on through RB, and through RB it's going to lose 20 volts. So 46 minus 10 minus 20 gives us actually 16. And then if we go through over here, it's going to either go through RC, RD, or RE, just like we saw before. And it's going to have 16 volts to give to one of those resistors. So that is another characteristic here, that if you took 10 plus 20 plus 16, that should equal your total voltage from your battery. And you only add one of the voltages from the parallel portion in because the current only goes through one of those resistors. So again, thinking about the current, it's either going to come out of the battery, go through RA, RB, and go through RC and go back, or it's going to come out of that battery, go through RA, RB, and then RD and come back through the center portion there. Or perhaps it's going to go through, find another one that's going to stick out. It's going to go through RA, RB, and then RE and go back. So each path only goes through one of the parallel resistors, so it gives the voltage to just one of those parallel resistors, and it has to be the same amount no matter which resistor that it goes through. So summarizing this, I have some stuff written down here. The total current goes through all of the resistors in series and then splits up through the resistors in parallel. So in this case, the current through total current is the same as the current through A and B, and then it splits up into C, D, and E. So if you added the current through all the parallel portions, they add up to be the total current, which I'm showing the numbers right here, right below here for this specific circuit. Whatever your values are that you did for the lab, these should also hold true. If you took your current through C, D, and E, it should add up to be your current through A and B. The current through the parallel resistors is inversely proportional to the resistance. So in this case, the 40 ohm resistor has twice as much resistance as the 20 ohm resistor, and it gets half as much current. So the hardest path gets less current. The path of least resistance gets the most current. The battery voltage splits up between the series resistors and one of the parallel resistors. So here's the numbers specifically for this circuit, that if you start with 46 volts for your total and you have 10 volts that goes to the first resistor, resistor A, and you have 20 volts that goes to resistor B, that means that either C, D, or E, oh, that's wrong here. It should say D or E. I'll fix that on your copy, D or E, those would be 16 volts, so that it adds together to be 46 no matter which path it actually takes. And this is kind of written out here, that some of the current goes through RA, RB, and then RC, and then some of it goes through RA, RB, and RD, some of it goes through RA, RB, and RE. So these parts right here, the parallel portion, is where it could be, the path could be different. I am going to stop the video right now and start a new one for some of the sample problems, and I highly suggest that you watch me go through a couple of the examples before that you start trying to do some circuit problems on your own.